Welcome to the Maine Science Podcast. I'm Kate Dickerson. Today's episode is a conversation I had with Amanda Smith, the Director of Water Quality Management for the City of Bangor. The world of water treatment is hugely scientific, wildly interesting, and hardly ever thought about. Hearing about how Amanda got into this world was a real treat, and having her talk about just some of the vital work that happens at the treatment plant was one of the best conversations I've had. I hope you enjoy it too. Today's episode is brought to you by Bangor Savings Bank, who was the tardigrade sponsor of the recent Maine Discovery Museum Gala, our 90s party. The whole Discovery team is grateful for their support. Amanda, welcome to the Maine Science Podcast. It is a delight to have you. Before we get deep into all of the millions of things actually you do for water quality for the city of Bangor, I was hoping you could give me a little bit of your background, where you grew up, how you got into science, and how you end up in this position.
Sure. I had no idea I was going to end up in this position. Sometimes I look around and I ask myself, how did I get here? As far as growing up, I think my journey into science was probably a little bit different than most. I grew up in West Warwick, Rhode Island, in a tenement apartment, living off pancakes and government cheese most of the time, with a household that my parents weren't high school graduates. So there was never any discussion of college, and certainly no expectation of college. And so that just seemed like something I never considered. I figured we were just going to hit the ground running, get through school, and start working whatever job we fell into, me and my siblings. That's essentially what I had done initially. I had gone to school for building construction for 1 year, realized that that was not viable. I needed to just focus on having an income and keeping food on the table. And I did that into my 30s. And my brother, in the meantime, had gone to school for wastewater in a very vocational environment, not a scientific academic kind of environment. And he had become the night operator in the Brewer treatment plant and kept telling me day after day, you've got to do this. This is so interesting. There's nothing I do that you can't do. You've got to get on this website, order these books, start doing your training. And so I finally, after about a year of listening to him, said, all right, I'm going to crack a book. One of the interesting things about this industry, clean water in general, is that the Clean Water Act was promulgated in the 70s. And at that time, there was a big boom to offer education, to get operators trained. They were building treatment plants across the country. Every major municipality was getting a brand new treatment facility. And where it happened so quickly, the education opportunity was there. And then these licensed operators got into these treatment plants. They were really good careers. They stayed long term. And slowly over the course of time throughout the country, the education opportunity started closing the doors on wastewater treatment in particular, because there was no job opportunity throughout the 80s and the 90s. Those jobs were filled and there wasn't a lot of attrition. So it's still one of our biggest obstacles right now, is that it's a career that you can't just go and sign up for at your local community college anymore. One of the main ways to start into this career, educational-wise, is through the Sacramento University. They have an Office of Water Programs. And that's how I started. It was just literally ordering a textbook and going through one course at a time and learning it. And the other hands-on piece really has to come, even to this day, from networking with local treatment facilities. So because my brother worked in the Brewer treatment facility, they allowed me to go in and play around in their laboratory and really learn hands-on and see how the operations work. And it wasn't just the science piece of it. There was also the mechanical piece and really feeling the industry out. And that was an excellent opportunity to feel my way through whether or not this was something that was going to fit me. And I'll tell you, I never considered what happened to things when you flush the toilet until I cracked that book and I was swallowed up by it. There's so much to it. And it's really a fascinating career choice.
So do you think most water treatment facilities in the country do just about the same thing? So like what you were learning in Brewer is translatable to Bangor. You mentioned Sacramento. Is the basic overview the same everywhere?
Generally speaking, yes. Every single treatment facility is different and very unique. So it's not as though I could just walk into another facility and hit the ground running, because they all have their own fingerprint. But in general, yeah, we're in the city of Bangor, we're a biological treatment system. I would say the majority of the facilities in the United States are biological. Some take it further and they have a membrane, maybe more filtration at the end, and it's a physical separation. There's some chemical treatment, but for the most part, it's biological and all of the fundamentals are the same.
So can you explain what a biological treatment facility is?
Sure. This is the funnest part of this job. It's absolutely what keeps me in this profession. I'll just back up for a minute. Yesterday was the first time I looked at what your podcasts were. I had a few minutes to sit down and I was listening to some of your guests. And I said to my husband, I said, I don't know why she's interviewing me. Like, she's got all these PhDs and highly academic scientists. And I don't know if she realizes I'm not a scientist. And my husband said, what do you think you've been doing for the last 10 years? So it really got me thinking. And in my mind, what I fell in love with about this wastewater treatment is the microbial life and learning about it and really fostering it. So in a way, in my mind, I've never considered it science. I've always thought of it more as farming. So we have all of this wastewater coming in, and every single day we have to do analysis to figure out what kind of, I'm going to call it food, because it's food for our microbial life. So what kind of food is coming in the door? And that changes wildly based on weather and seasons and what's going on with industries out in our sewer system. So every day we figure out how much food is coming in, and we keep on hand, millions and millions of what we call bugs, which is microbial life. They're mostly protozoa, bacteria, invertebrates of various kinds. And we spend every day trying to create an environment that they can thrive in. So we have to make sure that they have enough food. We have to make sure they don't have too much food coming in, meaning the raw sewage. We need to make sure we have enough bugs on hand to eat that food, but not so many bugs that they'll start eating each other. We have to, maintain their environment as far as temperature and the amount of oxygen that they have, because this is an aerobic system where they need to breathe and eat just like we do. So in my mind, I've always considered it more like farming, where we've got our pigs and cattle out here, and we need to make sure that they have what they need to be happy. And looking at them, under the microscope on a regular basis, you start learning which ones you want to keep more of. When you start seeing some undesirables beginning to thrive, you need to make changes in the system to prevent that from happening. I could go on, but so that's
no, this is great.
Kind of what I mean by a biological system.
I'm really glad your husband pushed back, because this is all science, super applied. Like you said, you never thought about what happens when you flush the toilet till you got into this. I think it's really easy for all of us to forget that just because something looks like it goes away, it hasn't. And there's just a bunch more left to do. So you've got your little farm system, which is an analogy I just love. This is the one area, one of many, of public infrastructure that I'm not totally up to date on. Does it work out so that you guys set it up so that the bugs, by the end of the process, you've got some solids that you have to do something with, but then the water itself is in good shape to go?
Yep, actually, so we mix the water and the bugs all together until they've had time to do their thing. And then one of the final steps, and it's something that we have to do every day, is we have to determine how many bugs we have. So this is, you can only see them under a microscope. So that's done by volume, by weight. And again, we're trying to determine and predict oftentimes how much food we're going to have coming in the next few days. And we decide whether we're going to keep the bugs or put them back to work, put them back in the system, or we waste them. So we can waste them. Typically, that would go out with the solids that we've removed from the wastewater up until just recently. And I know we're going to touch on this shortly, that was able to be composted because there's a lot of beneficial nutrients in those solids. So we would waste the bugs we don't need. And unfortunately, now those bugs go to landfill. But we do that every day. We measure and weigh and keep on hand what we think we're going to need.
So you alluded to it. I'm going to ask you to talk about 4 specific things that you, as the Director of Water Quality Management, have dealt with or have as part of the kind of overview of what you manage with your team with the city. So I'm going to mention the 4 of them quick, and then you can hit them in any order you want. Number 1 is sewer overflow, which is the great mystery that no one knows about. And as soon as they hear about it, they're just totally put off. Second is raising Atlantic salmon. The third is testing wastewater. In particular, it came into focus for a lot of folks with COVID. So how you can test for specific viruses or well-being or even prescriptions, right? You can test all sorts of different things. And then the fourth one is the PFAS, which is the one you just talked about. And I say those 4 knowing we could probably talk for the next 4 hours easily about all of those topics. So I'm being a little bit unfair, but if you could touch on those at a minimum, I'd like the people who listen to this to come away from it Number one, knowing about all the huge number of things that you all are working on, but also recognize that any one of these topics could easily send them down this cool rabbit hole of learning more about how their system works.
Sure. So I'll try to hit the two quickest topics, I guess. First being the combined sewer overflow. What a combined sewer overflow is when a mixture of stormwater and untreated sewage is discharged directly to a water body, in this case, either the Kenduskeag or the Penobscot Rivers, untreated. It did not go through the treatment facility, which is something that we avoid at all costs. So let's back up a little bit back to, I mentioned the Clean Water Act coming about in the 1970s. So we're at the end of a very hard learning curve as a society when it comes to water environment. So we'll take a city like Bangor. You could replace that with any old city throughout the entire world, essentially. If you think back to how they were developed back in the day, in the 1800s, initially people just disposed of their sewage however they please. After some time and some development, typically the natural tributaries, the natural streams that led to the rivers became the sewers. And in fact, a lot of our sewers here in the city of Bangor still exist where those streams once were. I don't know if you've heard about the new Davis Brook storage tank that we just completed down by the waterfront. That's named the Davis Brook storage tank because that sewage conveyed through the original Davis Brook. So that's sort of just the evolution of societies throughout the world. Over time, those brooks and tributaries became a nuisance and they covered them over with granite or brick. We still have sewer lines that date back into the 1850s here in Bangor. And believe it or not, some of them are in better condition than much newer sewer lines are. So fast forward to 1970, up until that point, really in Bangor up until the 60s, that sewage just went to the Penobscot or went to the Kenduskeag. There was no treatment. And then we started as a society to wisen up about what we were doing to the planet and to the water. And the federal government finally stepped in, created the Clean Water Act, started building all of these treatment facilities. In Bangor, it was just a primary treatment facility that we still operate today from the late 60s. That facility can do 43 million gallons. Hydraulically, that's all it can take in a day, 43 million gallons. There are times where we have snowmelt, rain events. I'm sure you recall the recent rain event that we had right before Christmas, where there's just too much water to get into that treatment facility. And so there's two choices. Either the stormwater and sewer that's combined is going to back up and start flooding streets and basements, or it needs to relieve itself out into the river. So this has been the case since that facility was built in the 60s, and the city has up to date removed 80% of the overflows. There used to be billions of gallons per year, even with the treatment facility here, that would not be able to make it into the treatment plant during those events, and it would overflow into the river. We are now down to, I believe it was 22 events last year where it would relieve itself. And we just completed a 3.8 million gallon storage tank down by the waterfront. We still have some more work to do. Our goal is by 2030 that we'll be down to 4 or less. We've been working very closely with the EPA, but the amount of infrastructure and investment is huge for removing that final 15 to 20% of those overflows. We also are trying to work around infrastructure from the 1800s. If you look at downtown Bangor, it's very difficult to remove all of that stormwater in a congested area like that that's been in existence for so long with very old infrastructure underneath the streets.
Yeah, and just to make it clear, this is not a Bangor only problem. A million years ago, when I graduated from grad school, I moved to Providence, Rhode Island. They were working on the very same thing. And as far as I know, they still haven't finished it. It's a huge issue in particular for the older cities in New England, and then, like you said, around the world. So it is a struggle to kind of backfill this type of infrastructure, recognizing what the impact is to the environment and figuring out how to address it.
It really is. And the other obstacle to that is, in general, people haven't realized the true cost of clean water. So when we all woke up in the 70s, the federal government essentially funded the majority of all of the infrastructure for cleaning water. And now these municipalities are sort of left holding the bag on their own to try to figure out how to complete the rest.
So that takes care of the sewer overflow. Which topic do you want to hit next?
We'll hit salmon because that is something I was really excited to come to Bangor. I've been working in the Bangor plant for 7 years, and that was the most fun thing to walk into the entryway and see a tank full of Atlantic salmon. And this was an idea of our laboratory director, I believe 12 years ago. I believe this is our 12th year, might be our 13th year. And our laboratory director has been with the city in the wastewater for 54 years. So he is just top notch when it comes to this industry in general, 54 years. So he started this Atlantic Salmon Project. And so we work with Inland Fish and Wildlife. We have a permit. We get little baby salmon. They're about 2 inches when we receive them in the fall, in September. And throughout the year, our laboratory manager replaces that water with our treatment plant effluent. So we're raising these salmon in the final product that we're putting into the river. And it's a huge testimony to the work that the operators here do in treating the wastewater, because salmon are especially susceptible to toxicity. Throughout the years that we've been doing that, we've lost one fish because he jumped out of the tank in the middle of the night. But other than that, we haven't had any succumb to any toxicity. I mean, the water that this treatment plant puts out is cleaner than the river water itself when it comes to all of the parameters that we analyze for.
First of all, your laboratory director has been in this industry almost as long as there's been an industry, which is interesting to think about. And how many salmon, I'm just curious how many each year you guys are able to raise?
We're only permitted 8 with our system. We would have to invest in a much larger system to be allowed more than that. But at the end of the year, we use it as an educational tool for, usually we'll have elementary age school kids come and help us release the salmon, and they go through a treatment plant tour and they look at our bugs under the microscope, and we use it as a way to reach the younger children and make them aware that this is a career that's an option for them, and it can be fun and it can be interesting.
That's really cool. So now we have COVID testing or PFAS.
Okay, we can just tackle them both. Well, we'll do COVID first. These are some of those things that I never thought that I would be involved in. You know, I never thought that I'd be working with the CDC on a worldwide pandemic. But this is something it's not brand new. They have experimented. There's been experimenting with wastewater in the past for things like, in some areas down in Texas, they were sampling wastewater to identify different attributes of population in different sections of the state. There are many things you could test for, but we've never done that here in Bangor. COVID testing was something that there were so many different universities and laboratories reaching out to all of us in the wastewater industry, trying to spearhead a way to anticipate COVID. When we all started first testing for COVID, it was almost too late. We would do the nasal swabs, but you already had COVID and you already were exposing people to COVID for 4 or 5 days before you even thought to test for it. And so we were trying to find a way to get a little bit more of a heads up. And it's not an exact science. One of the challenges with starting with this COVID sampling was trying to explain the variations in a sewer system to the scientists that were just trying to pull a sample and see how much COVID was in it. And this goes back to our combined sewer overflow conversation that we just had. And it took a while to really get them to understand that just because we sample today doesn't mean that it's not going to be diluted by millions of gallons of rainwater if we sample tomorrow. So it's been a challenge. And I feel like over the last 9 months, especially, they've really been able to work that out. And it has been useful. Bangor has its own health director, Patty Hamilton. It's been very useful data for her. It tends to give a heads up about a week in advance of what was going on with the nasal swabs. So it gives the health department and the CDC a chance to react and plan when a spike is coming, or a spike is here, but we haven't really seen it materialize yet. So that's beneficial. I think there's still a lot of refining to do. I think that it will continue to be refined. We're actually going to start sampling shortly for the CDC, put us in contact with another company and asked us if we would be willing to sample for things like influenza, monkeypox. It will also be another COVID sampling and RSV. And I imagine that they'll continue adding to that. But That's something that we've always worked as wastewater operators. We're used to the exposures that we have to things like hepatitis and other pathogens. So to now be providing advanced information to the CDC to help them and the general public is a different aspect of this job I never anticipated, for sure.
So do you all do the testing there, or do you collect the samples and send them out?
We send them out. So there's really only a handful of laboratories right now that I think are really focused on this. And that is a whole other kind of science, unlike any of the analysis that we do here. And I've had a lot of conversations with them. It's been a little bit challenging trying to communicate back and forth, like I mentioned, so that they understand what we're pulling for a sample here and what the variations can be. And it's been a challenge for us to understand the kind of science that they're doing. I mean, they are looking at DNA, they're looking at fragments of DNA, and we don't do anything like that in typical wastewater treatment.
Yeah, it seems to me that what that kind of testing requires, we've only just been able to do technologically. Like, we're finally at the point where that can be done. So developing these partnerships is only going to continue, it seems.
Yeah, I agree 100%. And I think it's definitely added an interesting dynamic to our work here.
All right, PFAS. It's such a difficult, in a way, topic because it just seems like they're everywhere. And I do know it's had a really large impact on wastewater treatment facilities.
It sure has. We call it an emerging contaminant. And we've, as an industry, run across emerging contaminants. We always will, I believe. I'm sure that people remember the BPA. Everything was BPA free. You know, when we really started becoming educated about mercury, that was another example of an emerging contaminant that we had to take a step back and figure out how to deal with it. PFAS is an animal of its own, and there's so many of these compounds. And I'm sure people have seen headlines about the forever chemicals. The whole nation is looking at the state of Maine right now on how we're handling PFAS. And one of the things that the legislature did last session was LD 1911 put a prohibition on the land application of wastewater sludge. And that essentially changed the way we do everything with handling our solids. I guess I should take a step back and explain what PFAS are. They're fluorinated compounds that are nearly impossible to destruct. They bioaccumulate in our bodies. We do know that. They've been linked to certain health hazards. There's still so much research and science that needs to be completed on what those health hazards really are. But these compounds, and there are thousands of them, are in everything that we love to buy. So everything that we've purchased, and they've been using them in manufacturing these products since the 1940s. But if you're purchasing things that are non-stick or heat resistant or rain resistant, oil resistant, all the things that make our products durable and make our lives easier have been filled with these compounds. And we're still learning. We just started sampling here at the treatment plant. We're sampling the water in the beginning of November was our first actual sampling. It took that long just to have an EPA approved standard method that was agreed upon on how to go about analyzing for these compounds, and for the DEP to be able to train wastewater laboratory personnel on how to properly sample for them. It's extremely easy to contaminate these samples. For example, you can't wear deodorant if you are sampling for PFAS. You can't wear cosmetics. You can't use Sharpie markers. You can't use Post-it notes. There's just all these things that we are just surrounded by every day we're not able to use. If you saw our laboratory personnel going out to sample PFAS, you would think they were having a heck of a day because they're going to look like they didn't get ready for work. But they're so easy to contaminate. And we're looking for these compounds in parts per trillion. That's the minimum detection limit right now. But they're still trying to refine that because the EPA has suggested some drinking water limits. They haven't set them yet, but in the parts per quadrillion. And that is essentially zero. So they haven't come up with a method to even detect them at those levels. So it does make it difficult. One thing that we're doing in Bangor, a lot of these compounds are associated with industrial and manufacturing. So we were required to sample the plant effluent to see what levels of these compounds might be in there. So we decided to also sample the influent, what's coming into the treatment plant. I've always been a fan of we should never sample what's going out if we don't know what's coming in. We should be able to compare. And in addition to that, we're taking an extra step here in Bangor by sampling residential only areas so that we can compare that to what's coming into the treatment plant. And that will help us identify if there are any industrial contributors that may be sending higher amounts than what we would get from normal, regular residential households. And so far, what we're seeing, and we're very early on in this, but so far what we're seeing is there's not a big difference between what's coming into the treatment plant, what's coming out of regular households.
Oh, that's really interesting. I was going to ask you if the system is set up so that you can separate large-scale wastewater dischargers compared to a neighborhood full of people who are connected to the sewer. So that is possible to separate those two out?
We don't necessarily separate them. We could prevent them from discharging. So that's another interesting aspect of wastewater treatment. We are a publicly owned facility, and we first and foremost have to always be at the ready to accept residential and regular commercial wastewater. Industrial wastewater is sort of icing on the cake. We can accept it if we can accept it. So we do permit our largest industries here in the city of Bangor and also the towns of Hamden and Herman. I didn't mention that we also treat their waste. And we have regular inspections and we do sampling of those. So we have some industries, for example, Pine Tree Landfill leachate comes here, de-icing fluid from the airport. Those are some big contributors. We've got several larger industries and we sample them separate so that we know what's coming in just from those industries. And then again, we go back to our bugs and see what they like and dislike and whether or not they can treat those. But one of the most challenging parts of this PFAS issue is these treatment facilities are not designed to treat for PFAS. So this PFAS is either coming out in the solids and being landfilled now, or it will pass through the final plant water. And this is why your podcast and things like that are so important, because that technology has not been invented yet. There are scientists around the world right now just scurrying to find the ultimate solution for destroying these compounds. And so far, no one has found a way to destroy them on an industrial size level that would be even remotely economical, like a wastewater treatment facility. So we're all waiting with bated breath for someone to invent a way to take care of these compounds. And we need scientists and new scientists and inquiring minds to come up with that solution for us. And I guess the last sort of thing that I'll hammer on that topic is these compounds aren't the only thing. There are certain pollutants that we sample for every day. We can't sample for everything. We don't know everything that's in the water. There's things in the water that we do know. They're not something that's regulated by the DEP or the EPA, like microplastics, like pharmaceuticals, things like that these facilities weren't intended to treat for. And those are all things that still are to come. They need to be invented. We know socially we've become much more environmentally aware over the last couple of decades, and we know that these are things that are going to have to be addressed in the future. And there's no means to address them yet. It doesn't exist yet.
So what could homeowners, listeners, commercial businesses do to make your life a little bit easier and not put down into the toilet or the sewer system, but dispose of in a different way?
That's such a good question. I'm so glad you asked that. You know, your everyday things, biggest culprit is grease and non-flushable rags. Those are the things that give us headaches and keep our operators very, very busy and dirty. But on a more broad scale, this PFAS topic, for example, we are unknowing receivers of these compounds. We didn't know they were there. Nobody knew they existed. And now we know they're there. We're the end receivers and we have to do something with them. And it's going to come down to consumer choice. It really has to be consumer choice. There have been some laws already on the books to prevent the manufacture of some of these compounds, but not all of these compounds. And the laws that I know of that do exist still only impact U.S. manufacturers. It doesn't impact anything being imported from overseas. So it really is going to come down to a personal choice. Find that deodorant that doesn't contain these compounds. It's in your best health interest anyway. So just find the fast food wrappers that don't have. I've begun to see nonstick pans that say PFAS free, go with those choices. And it might not be as comfortable. Maybe it won't be as nonstick as your PFAS-filled frying pan, but you're going to be better off health-wise in the long run, and it will help us come up with a global solution faster.
Where do you stand on garbage disposals?
Honestly, garbage disposals are probably going to cause a problem in your own private sewer line more so than they will in the public lines. So it's just like the PFAS. It's in your own best health interest to make the right choices. It's in your own best interest to make the right choices about what you put down the drain, because chances are it's going to harm your own personal sewer line before it harms ours.
And that sewer line is the one that connects to the public line, right?
That's right. Most municipalities, the homeowner owns the line from the home to the public sewer line. And you want to protect that as much as you want, if not more than you want to protect the public sewer line.
So is there any part of wastewater stuff that I haven't hit that you would like people to know that you are dealing with? I know we hit these 4 topic areas just because I thought they were a good broad range of very different things, but have I missed anything that you all have to deal with relatively regularly that we might not think about?
Well, you hit all of the hot topics that we're dealing with right now. I think the one thing that I would point to is it's very easy to get wrapped up in these hot topics. PFAS is going to be a very expensive fix. It's very time consuming. Some of these extra things that we're adding, like the COVID or the other pathogen sampling, that's added effort and time, but it's worthwhile. It's easy to get wrapped up in these new hot topics and forget that we have infrastructure from the 1850s. There was already a seemingly insurmountable need out there, and everything costs. Everything has a cost. These costs are borne entirely by the sewer rate payers. It's very easy to think that we should invest heavily in hot topics, but we can't forget about the infrastructure that's there, because that infrastructure is what's keeping these rivers clean.
I think that's a great place to end. It's so interesting to me because I'm just enough of a policy geek when I was doing policy work that I just thought infrastructure was really cool, and I couldn't understand why more people didn't talk. I mean, I know the answer now because I'm older, but it's really important. It's really cool stuff. And there's this whole other undercurrent of work that is being done with it. So first of all, I appreciate you explaining some of it. And secondly, I really appreciate your time and the work that you're doing. And I hope that you've been convinced that you're doing really cool, important science.
Well, thank you. I appreciate that. And you're welcome to come for a tour anytime. We give tours all the time. If anyone is interested in seeing this firsthand, we would love to have anybody come see what we do.
What's the best thing to include in the show notes? Just in general contact number?
Yep. We can just do the regular plant number, 207-992-4470.
We will include that. I actually love plant tours, so I might take you up on it. I really appreciate it.
Okay.
Thanks for listening to the Maine Science Podcast. Make sure you never miss an episode by subscribing on your podcast platform of choice. And please leave a rating and review. It will help more people find us and help spread the word about some of the remarkable people doing science in Maine. The Maine Science Podcast is recorded at Discovery Studios at the Maine Discovery Museum in Bangor, Maine. The Maine Science Podcast is executive produced and hosted by me, Kate Dickerson, and edited and produced by Scott Loiselle. The Discover Maine theme was composed and performed by Nick Parker.